Hi everybody. My name is Jan Vesely and I am the project manager and the rock expert by Amberg Engineering. I would like to introduce you one of the projects on which I am actually working. The project is called Västlänken and it is situated in Sweden in the second largest city, Gothenburg. The project focuses on build of 8 kilometers long new double railway track where almost 6 kilometers will go through the tunnels under the city center. If you look at the longitudinal profile, you can see that one of the design challenges is the geological situation. There are parts of the tunnel which are located in the rock, while other parts are going through the clays, and this changing of geological conditions makes excavation difficult. Moreover, the part of the project are also 3 new underground stations called Station Centralen, Station Haga, and the Station Kirchwegen. These stations are huge caverns with the span up to 50 meters. Today, the project is in the construction stage and it is planned that the start of the operations will be in year 2026. Amberg Engineering is responsible for the design of the Haga station. This station is located near to the Haga district, which is a popular visiting place for the tourists and for the local people. You can find here typical 19th century atmosphere. You can admire nice wooden houses and enjoy sitting in the restaurants and cafes. As you can see on the picture, the station is mainly situated below the park. However, it is also undergoing under the old church and therefore requires safe design. As I have mentioned before, the geological conditions are variable and this is also valid for the Haga station. The part of the station is located in the clay and it will be excavated by cut and cover method. The main part shown in the picture by blue square is situated in the rock and will be excavated by drill and blast. If you look at the typical cross section, you can see that the span is almost 50 meters and the concept of the station consists of 2 big caverns and the row of concrete columns and beam in the middle. To ensure the safe design of the station, we have set the following calculation strategy. First, we carried out the 3D numerical analysis using continuous model in the software Flex 3D. The purpose of this analysis is to check the global stability, to identify stress concentrations, to study the influence of the weakness zones and low rock cover, and also to estimate the loads in the concrete pillars. For the detailed verification of the rock support, the 2D analyses have been carried out in the most critical cross sections. For this analysis, we have used the discontinuous model and the software RS2. When we are talking about the 3D analysis, we have set up a complex model of the whole station without any simplification. There is no simplification in the rock and surface terrain. There is no simplification in the geometry of the station. The whole model is 500 meters long, 500 meters wide, and up to 100 meters high. All the weakness zones are considered in the model, and also two stress scenarios are modeled, the gravitational and the typical stressed field. To check the behavior during the construction, the whole excavation process is simulated by step-by-step excavation with the round length of 6 meters. To be able to estimate the loads in concrete columns and beam, we have modeled them without any simplifications, using volume elements and elastic material model, as you can see on the picture on the left side. The results of the 3D analysis is a complex behavior of the station during and after excavation. As you can see on the pictures, we were able to read the deformation of the station, the settlement on the surface, and also identified the potential areas of the loosening rock based on the results of principal stresses and strains. One of the critical topics is the design of concrete columns and beams in the middle of the station. We have used our model and evaluated the forces acting in these columns by integration of the stresses. These forces are used later for separate detailed design of the concrete structures, considering also the temperature loads, creep, shrinkage, which is normally difficult to simulate directly in Flex 3D analysis. Beside the internal forces, it can be also possible to study the stresses in the shotcrete between the column and the rock, the deformation, and in general to identify the most critical areas. Some examples of results as a displacement or vertical stresses are presented in the pictures on the right side. In the second step, the 2D analyses have been used mainly for the verification of the rock support. In this case, the discontinuous model has been used and the joint has been set based on this discontinuity orientation from geological prognosis. As like in the 3D model, the both stress conditions have been simulated and the model is prepared without any simplification. The simulation is again done by step-by-step excavation, and the pre-relaxations are based on the results of the 3D analysis. The results of the analysis have been used for the verification of the rock support. As you can see on the picture on the right side, the capacity of the bolt has been verified and the shotcrete has been checked against the bending and shear failure. Based on these results, we have been possible to say if the rock support is enough. I hope that you have enjoyed my presentation. Thank you for the listening, and if you will have any questions, just contact me by the mail. Have a nice day.
I was working on a metro project in Stockholm for almost 2 years. We from Untitled Engineering were supporting the main designer with our expertise in tunneling. My colleagues and I were doing numerical analysis and 3D modeling for the new metro line. The ground conditions and the design methods in Sweden are completely different from what I was used to, so it was very interesting for me to get a new impact of other approaches. For me, it was a new experience that almost everybody I was working with was sitting in Stockholm, and I was working remotely, knowing them just from several Skype meetings. I got in touch with online organization and communication tools, which helped us working together as a competent team. And of course, I really enjoyed visiting Stockholm twice.
Ever since I started working for Untitled Engineering, I was fascinated by new digitalization methods that are now becoming a big part of the building industry. The design of a metro line in Stockholm was my first project where I got in touch with 3D modeling as such, and I could quickly realize that implementing time and cost directly into the 3D model is a step towards the future. I got an impact on how to visualize conflicts and avoid installation clashes at a very early stage of a project. Since metro design is always in heavily built up urban areas, there were also a lot of adjacent structures or even other tunnels that had to be considered in the design. I really enjoyed discussing all these challenges with my experienced colleagues and finding solutions for those problems. In one sentence, I would say, it's fun because it's challenging.